This next demo focuses on an area of research that I find incredibly intriguing. I think this has potentially game-changing applications in the real world in terms of helping people. Now, the idea is that this is Wi-Fi imaging. So taking your standard Wi-Fi signal that you already use to great effect, but making it more useful. Now, the reason for that is that if you think about a Wi-Fi signal propagating out of your router in, say, a home scenario, well, a lot of that signal gets wasted. So you connect 10, 15, maybe 20 devices to it, but the rest of that signal is just propagating out and doing nothing. It's just there ready to be connected to. But if you could image it, if you could see what that signal looked like, and you could see what it looked like when a physical object blocked that signal, well, then the data might become something useful. Now, what we've got here is a concept router from a company called Celeno. Now, the idea of this router is, yes, it's propagating out Wi-Fi in the traditional way, but it's then using a piece of software called a Doppler spectrogram, so an imaging tool to look at that Wi-Fi and a bit of machine learning to translate what it sees into human-readable data. So in the video, what you're going to see is that as our volunteer walks away from the router, the data starts to tell us, one, we can see the movement through that signal, but two, it translates it into movement data, so proximity to the concept router. Now, understanding walking, that's got potentially some quite powerful applications. So we can understand footfall through an environment. We can understand when people are entering or leaving an environment. That might be quite a powerful piece of data. However, there is further application here, because actually what you can do is you can interpret detail, more intricate detail, such as the difference between sitting down and standing up. So suddenly we've gone from just understanding foot flow through an environment to actually understanding the difference between delicate movements like sitting down and standing up. Now, for me, this immediately has applications around connected care. So could I put this in an elderly relative's home? And actually it's not cameras like you would traditionally have, so it's not as invasive. It's not like the necklaces or the little wrist bracelets that you get, but it is still allowing me to monitor. And so I now understand, actually, my nan has gotten up. She's gotten up today and she's made a cup of tea. Or no, she hasn't moved from her chair all day. And so I need an intervention. I need to go and get her moving, or I need to send someone over if I can't go over myself. But then the really powerful applications come, because actually, if it's able to do delicate moves like understanding the difference between sitting down and standing up, what this can also do is understand more dangerous actions such as falling over. And there we go, we see an immediate alert there. We understand immediately that our volunteer has fallen over, and we get that alert that says, okay, we need to act. Now, again, in that connected care kind of scenario, thinking about assisted living, well, this might be the difference between an elderly relative falling out of bed in the middle of the night and spending 18 hours on the floor, or actually being found right away. There's a problem, we alert someone, and suddenly we have our safe scenario where they can be rescued in fairly short order. Now, this is a research piece at the moment. It's not something that is commercially available, and that's because there's research going on into how to get this absolutely right. It's got to only ever report a fall when there really is a fall, because if you can't trust the system, well, then you haven't got a good system. And there are things that can be done to potentially make that detection a little bit stronger. So through the use of things like multiple access points or whole home Wi-Fi access points, you could triangulate, in theory, that signal. So you could understand and triangulate that to get a more reliable readout. The other thing about this is, obviously, we start to get into some ethical type of zones here around how that data gets shared, because ultimately this does, even without cameras, even just using Wi-Fi, it still does allow us to track the movement of a person through a home. So in the scenario of assisted living and connected care, what we really want to see is that that data only gets shared with the right people, so a loved one or a carer, and only shared at the right times. So it's got to be put to good use, and actually that's part of why it's got to be right before this can ever be released as a product in the real world. But ultimately what this is doing is showing us the potential of Wi-Fi imaging, so using literally just your Wi-Fi signal that you already have to create imagery that gives us useful data that can allow us to potentially keep a person in their home a lot longer than we might have done before. There are then further applications around security. So if I was to go on holiday and suddenly I started seeing movement in my house, even though I knew that I didn't leave a key for anyone and didn't have anyone going in to check on the plants or anything, well, that might be a thing that I would be concerned about. So there are potential applications around that. Potentially from a safety perspective, things like firemen might want to actually use this to understand if there are still people inside a space that's on fire. There's all sorts of applications like that that can be explored. But the point is, we've got to get that learning piece right, of understanding that it only reports a fall when it really is a fall, or only reports sitting down when it really is sitting down, because if the data is wrong once, well, then we're never going to trust it. So really, really fascinating piece of research, something that I think, as I said, has potential game-changing applications in the world, really. If this can save one person, it's totally worth it. And so for me, this is one of the most exciting pieces of research that I've seen going on at the moment. It really does have the potential to save people's lives and keep people safer.